All digital audio workstations convert analog sound into digital data in order to record it. After conversion, the digital waveform shows up as discrete steps. Using more steps and using deeper steps gives you a more accurate waveform. This is why using higher sample rates or bit depths results in higher quality. So far, so good. But what happens when you have to convert to a lower resolution? For example, say you're working at 96K and 32 bits, but you need to output to a CD, which is 44.1K and 16 bits. How do you fit all of the high-resolution steps into the new format? The system has to round off or quantize the data that doesn't fit. This can introduce quantization errors, which sound like this. Solving this problem is where dithering comes into play. Dithering is a mathematical process that adds noise to a digital signal to fill in the gaps and round off the steps when converting from one resolution to another. How well a system makes this conversion is what sets world-class systems like WaveLab apart from more average platforms. But how can adding noise make something sound better? It works because adding carefully shaped noise smooths out the quantization errors. This allows the human ear to hear the music and not hear the noise. If you're extremely clever, you can figure out secret ways to place the dither noise in parts of the audio spectrum that people can't hear in the first place, which is exactly what happens in the revolutionary dithering process known as MBIT+. First, take a look at the master section. To select an activated dithering algorithm, click the dithering plugin slot in the dithering pane. Then select one of the options from the pop-up menu. The general rule is that you only need to dither when you change resolution, but keep in mind that WaveLab uses an internal floating-point 32-bit resolution for supreme audio quality. This means that as soon as you perform any kind of processing, the audio data is treated at this higher resolution instead of the original 16 or 24 bits. So dithering is usually a good idea. And you should always make sure that dithering is the very last step in your signal chain. Use the first drop-down to select your target bit depth. The next menu sets the type of dithering. There are two traditional dithering types and the proprietary MBIT. Use the amount menu if you select MBIT+, and the normal selection should give you great results most of the time. None and low can leave some quantization error, but less overall noise. The higher settings will completely eliminate nonlinear distortion, but introduce a slightly increased noise floor. When using MBIT+, this section controls the amount of noise shaping. The choices range from no noise shaping to very aggressive noise shaping, providing approximately 14 decibels of audible noise suppression at the expense of a higher noise floor. The shaping menu gives you options to make the dithering even less audible. Simple performs a basic high-pass filtering on the dither noise. Clear moves the noise towards the Nyquist frequency, which is an inaudible range at roughly twice the original frequency. Psych 5 and Psych 9 move the noise away from audible bands, which is sort of like putting it in the cracks between the piano keys, if you will. The option for auto blanking works like a noise gate. It mutes the dither output after about half a second of silence is detected. Doing this prevents the listener from hearing the dither noise during quiet periods, like you have in some classical pieces. The Minimize Peaks option prevents the dithering stage from randomly generating a noise pulse that could cause clipping during output, especially with extremely hot program material. And finally, harmonics suppression is a slightly different control. It doesn't create any dither signal, but helps improve sound quality by moving the original stair steps away from audible frequencies. It's basically an alternative to dithering, and you would only use this on rare occasions when dithering was not being used. Another fantastic tool included with WaveLab 8 is the Curve EQ by Voxengo. Curve EQ is a spline equalizer, and that means that the frequency response is shown as a smooth, curvy line. It also has a built-in spectrum analyzer to show you how the EQ is altering your sound. You can click to place nodes and double-click to remove them. Or you can switch to freeform mode and then draw the line by hand. You can engage multiple curves, and then you can see the net results all on one screen. Now, Curve EQ is a terrific all-around equalizer, but it also uses something called spectrum matching technology. This lets you transfer the spectral shape of one recording to another. In other words, you can copy and paste the EQ curve from one piece to another. This can allow you to transfer existing, time-proven EQ settings from one mix to another. You can also use this to help make sure that the overall sonic texture is consistent from one song to another on an album. Now here's a quick run-through of how to use spectrum matching. You'll need a snapshot of each spectrum in order to use matching. And just a note, set the mode editor to average for best results. And you'll need to run averaging for several seconds until the visible spectrum becomes smooth and stable enough to use. Then press Take. Now, repeat this process for the second source. Then, select Reference and Apply to as desired. Then, activate it. Now, here's an example of the second take before and after the spectrum matching of Curve EQ. Another great plugin included with WaveLab 8 is the Brickwall limiter. This ensures that the output level will never exceed a set value. A Brickwall limiter has an extremely fast attack time to reduce even short audio events cleanly. And you have separate meters for input and output, as well as the amount of limiting. The best place for this limiter is at the end of the signal chain just before dithering. The threshold control ranges from -20 to 0. The Brickwall limiter only impacts signal levels above the threshold. This is one of the primary differences between a limiter and a compressor. The release control determines how long it takes to return to normal after the signal falls below the threshold. Auto mode should work well for most situations, but you may want to experiment with the release control for certain effects. Activate the link button if you want the limiter to use the channel with the highest level for analysis. Otherwise, each channel is analyzed separately. Finally, the Detect Inner Sample Clipping option allows the Brickwall limiter to detect and limit signal levels between two samples. This prevents distortion during the digital to analog conversion. Now, one tip, the Brickwall limiter is designed to control occasional peaks in the signal. If the gain reduction meter is constantly lit up, try raising the threshold, or try lowering the overall level of the input signal. WaveLab 8 also introduces a relative of the Brickwall limiter, the tube compressor. This is a versatile compressor with integrated tube simulation, which allows you to achieve smooth and warm compression effects. The VU meter shows the amount of gain reduction. The controls are really straightforward. Drive controls the amount of saturation. Input determines the amount of compression. And the higher the input gain setting, the more compression is applied. The limit button bumps up the ratio for a limiting effect. As with any compressor, attack is a key parameter. Attack determines how fast the compressor responds. If the attack time is long, more of the initial signal passes through unprocessed. For example, the attack control is important when trying to reduce the pumping in a mix bus compressor.